that, we simplify, and what do we get? We get y is equal to -2. So your vertex will be 1, -2. Okay, the third step, we're going to find the y-intercept. Well, here's your function. What is the y-intercept going to be, class? Just what? 1. The y-intercept is just 1. Okay, and that's going to be your c value. Remember, the y-intercept is 1. This is where the graph passes through 0, 1. Where this is where it crosses the y-axis. Fourth step. Find 2 more points on the same side as the axis of symmetry as the point containing the y-intercept. Since the axis of symmetry, x equals 1, choose x values less than 1. Now, they chose x equals -1. Can anybody tell me why they did this? Why is it that they're choosing values on the side of the point containing the y-intercept? Why do you think they're doing that?
Because we want them on the same side of the axis.
Why?
Because that's what it says.
Why is it? Okay, good. So if we know them on one side, we know a parabola is symmetric with respect to what? Right, exactly. So if you know the points on one side, then all you have to do is reflect them on the other side. Right? So this is why they are doing this. And they're just picking these other points. So they pick points less than 1. So when they plug in here, you have x equals -1. Your y value that corresponds to that is 10. If they let x equals -2, another point here, they're going to get y is equal to 25. So the 2 other points that they have here is -1, 10, and -2 and 25. Okay, and those are going to be on the same side as the y-intercept, as we will see in just a second. Now, they say graph the axis of symmetry, the vertex, the point containing the y-intercept, and 2 more points. Now, let's look at what they have done here in this particular graph. So now, first thing we have our axis of symmetry here, x is equal to 1. They found the vertex here, 1, -2. We found the y-intercept here is at 0, 1. And then these are the 2 additional points that they found on the same side as the y-intercept. Now, once you have these points here, all you need to do is just reflect them. Now, how do we reflect them? What do we need to do to reflect them?
Fold your paper in half.
Fold it in half? Okay, you can do that, but...
Well, they're going to have the same y value.
What's the kind of easier way we can do it to reflect them? Count what? Okay, very good. So we're going to count how many, count the x values, how many they are from the axis of symmetry, and then we know the height of them is going to be the same. So for instance, if we reflected this point here, it's going to go right here, because we're only 1 point. The distance here is about 1 point, so we just reflect here. So this point, you have to count it, how many, you have to count the distance it is from the axis of symmetry, not necessarily the y-axis, but the axis of symmetry. So don't confuse that. You know, you have to count the distance from the axis of symmetry. So when we do that, let's look at our graph, and here's our graph with our other points reflected. Questions on that? Okay. So now, helpful hint, because a parabola is symmetrical, each point is the same number of units away from the axis of symmetry as its reflected point, which is what we just stated. Okay? Okay, so now let's look at an application. Says the height and feet of a basketball that is thrown can be modeled by f of x equals -16x squared plus 32x, where x is the time in seconds after it is thrown. Find the basketball's maximum height and the time it takes the basketball to reach this height. Then find how long the basketball is in the air. Okay, so they're asking us for a few things, but we can work it out in steps. So the first thing, understand the problem. The answer includes 3 parts: the maximum height, the time to reach the maximum height, and the time to reach the ground. Okay, so can somebody tell me, what do you think as it relates to some of the characteristics and the properties that we were talking about in a parabola? Can anybody tell me, what do you think the maximum height will be? What is it? Okay, so the maximum height, yes, it will be a vertex. What about the time to reach the maximum height? What would that be?
Depending on the acceleration.
What do you think?
Negative b over 2a.
Okay, what would the time to reach the maximum height would be what?
1.
It would be what?
Yeah, it's going to be 1.
It's not the same as the okay, what, say it again one more time.
The x coordinate for your vertex.
Okay, yes, thank you. Yes, it would be. So the maximum height is going to be your what? Okay,
It's going to be
it's going, that's
on
what
the
I'm
axis of
looking for.
symmetry.
It's going to be your y, the y coordinate, and the time to reach the maximum height will be your what? It's going to be the x coordinate. Okay, and what about the time to reach the ground? It's going to, what's that one going to be? Okay, good. Thank you, Phil. Okay, so now let's look here. Now, make a plan. Find the vertex of the graph, which is what you all said, because the maximum height of the basketball and the time it takes to reach are the coordinates of the vertex. The basketball will hit the ground when its height is 0. So find the zeros of the function. You can do this by graphing. So it makes sense that it will hit the ground when the height is 0, because of course if there's no height, it's going to be on the ground, right? So that means we'll have to set the function equal to 0, right? Are we clear?
Right.
Okay, so first thing, you're going to find your axis of symmetry. Okay, so if you have a function there, you can see minus b over 2a, the axis of symmetry, x equals 1. Find the vertex. Once you find your vertex, you see your vertex is going to be, your y coordinate for the vertex is 16. So the vertex is 1 and 16. Now, find the y-intercept. Identify C. We know that the vertex, the y-intercept is 0. The graph passes through 0, 0. Now, it says graph the axis of symmetry, the vertex and the point containing the y-intercept, then reflect the point across the axis of symmetry. Connect the points with a smooth curve. Now, can somebody tell me, what does this point here represent as it relates to our basketball problem?
Maximum height.
This represents,
Apogee.
okay, so can you tell me in words what these numbers mean here? In words.
After 1 second of the ball is maximum height, that's 6 feet.
Of 16, what is that?
What is it?
Feet?
What was it? Inches?
16 feet. Feet. Okay, and what about, what about these points here? What do they represent? What does 0, 0 represent? Phil?
It represents the starting point and the starting time.
Okay, the 0.
Starting height and starting time.
Okay, and what about 2 and 0?
That's the ending time and the ending height once it landed in the ground.
Okay, so how long do you think that it was up in the air? Okay. And that's up. And see, the vertex is 116. So at 1 second, the basketball has reached its maximum height of 16 feet. The graph shows the zeros of the function are 0 and 2. At 0 seconds, the ball has not yet been thrown, okay? And at 2 seconds, it reaches the ground. So therefore, the basketball is in the air for 2 seconds, like Phil just stated. Questions on that? Okay. Okay, so the vertex, remember the vertex is the highest or lowest point on the parabola. Therefore, in the example, it gives